Today I'm going to be talking about modular arithmetic. This is a way of working with integers, and it comes up all the time in computer science and in math, in a lot of interesting subjects such as cryptography and number theory. And so it's really important that you have a strong understanding of this fundamental concept. To begin, I'm going to talk a little bit about division. So specifically, let's say we have a number, an integer n, and we're going to have another integer d. And if we divide n by d, we're going to be able to fit it some number of times, and then we're going to have a remainder. So, for example, if n is going to equal q times d plus r. So that means basically, if you divide n by d, it will fit q times plus a remainder of r. So you can think of q as the quotient and r as the remainder. So for instance, 7, if n equals 7 and d equals 3, then 7 is going to equal 2 times 3 plus 1. We can fit 2 3's into 7, plus we have a remainder of 1. Now there's one issue with this, and that issue is that there are other numbers that could match this equation. For instance, we could have 7 equals 1 times 3 plus 4. So there's a different q and r that satisfy this. And the way we can overcome this is we can force r to be between 0 and d. Specifically, we're going to make it be greater than or equal to 0, and we're going to make it be less than d. Sorry, not less than itself, less than d. So what this is going to do is it's going to make sure that our result is always unique. So now we can't write it this way because 4 is greater than 3. This r is greater than this d. So that means we can subtract a 3 from it. We'll get 1, and then we get one more 3 over here, and that's what we had before. That's the correct way to write that. Alright, so what we can do with this is we can classify numbers, we can group them, based on their remainders when divided by some d. So for instance, first I'm going to start with a d of 2, and we're going to call this modulo 2 arithmetic. So basically we're going to take all the numbers, divide them by 2, and see what their remainders are, and we're going to group them. So 0, it equals 0 2's plus a remainder of 0. 1 is equal to 0 2's plus a remainder of 1. 2 is equal to 1 2 plus a remainder of 0. 3 is equal to 1 2 plus a remainder of 1. So if we group all the numbers based on their remainders, the things with a remainder of 0 are going to be 0, 2, 4, 6, 8, and so on. And the things with a remainder of 1 are going to be 1, 3, 5, 7, and so on. So obviously these are the even numbers, and these are the odd numbers. And that's because even and odd is really just arithmetic modulo 2. It's grouping the numbers based on their remainder when divided by 2. Even numbers have a remainder of 0, odd numbers have a remainder of 1. But now most people are very familiar with even and odd numbers, but they aren't familiar with the fact that we can do this with other numbers besides 2. For instance, let's look at things modulo 3. 0 is going to equal 0 3's plus a remainder of 0. 1 is going to equal 0 3's plus a remainder of 1. 2 is going to equal 0 3's plus a remainder of 2. 3 is going to equal 1 3 plus a remainder of 0. 4 is equal to 1 3 plus a remainder of 1. And 5 is equal to 1 3 plus a remainder of 2. And so on. So now we have 3 different types of numbers because we have 3 different remainders that they give. So the ones that have a remainder of 0 are 0, 3, 6, 9, and so on. Ones that have a remainder of 1 are going to be 1, 4, 7, 10, and so on. And things that have a remainder of 2 are going to be 2, 5, 8, 11, and so on. So you can think about this exactly the way you think about even and odd numbers, but instead of having just 2 different types of numbers, we now have 3 different types of numbers because there are 3 possible remainders when you divide by 3. Alright, but we can carry this on. We could do modulo 7, and then we'll have 7 different remainders. We can do modulo 10, and let's stop and look at this one. Let's see what numbers have a remainder of 0 when divided by 10. 0, 10, 20, 30, and so on. What about a remainder of 1? 1, 11, 21, 31. With modulo 10, it's easy for us to see what class a number belongs to, because it's just the last digit of the number. So for instance, 9, it's the numbers that have a remainder of 9 modulo 10 are going to be 9, 19, 29, 39, and so on. Now this is really cool. It's got a lot of properties that we can use, and what we're going to do is we're going to work within systems of numbers, and basically we're going to say that all the numbers in the same group are the same. We don't care about which one it is. All we care about is their remainders. So it's kind of a restricted number system. Instead of having an infinite number of integers, we have a finite number of integers to work with. So let's look at modulo 3. The only 3 numbers we have to work with are 0, 1, and 2. That's because 3 is really 0 in this system. 6 is really 0. 5 is really a 2 in this system. So what that means is if we add some things together, let's say we have 1 plus 2, that's going to equal not 3, but 0. Now it also equals 3, but 3 is the same as 0 in our system. And when we say things are the same, another way to say that is to say they're congruent. They're in the same class. It's also called a congruency class. And the symbol to do this is the triple equal sign. So 0 is congruent to 3, and they're congruent to 6, and congruent to 9, and so on. 1 is congruent to 4. So we only want to work with the easiest representatives of each class to work with are the 0, 1, and 2. So 0 plus 1 is going to give us 1. 0 plus 2 is going to give us 2. 1 plus 1 is going to give us 2. 2 plus 1 is going to give us 0. 2 plus 2 is going to give us 1. It takes a little bit of getting used to, but these systems will be very useful to us. Now, people actually use this type of system all the time. For instance, let's think about if we were doing modulo 12. And let's say we're adding, so modulo 12, there's going to be 12 different classes, 0, 1, 2, 3, all the way up to 11. Let's say we were adding 9 plus 6. Well, that's really equal to 15, but really that is congruent to 3 modulo 12. And so 9 plus 6 is really 3 in this system. And one way you can think about this is if it was 9 o'clock at night and you stayed awake for another 6 hours, then it would be 3 o'clock in the morning. Time, when you're using a 12-hour clock, time is a system modulo 12. We have this looping effect where we add hours past 12 o'clock and we go back to lower numbers. And so I'm going to make another video talking about some applications of this and some properties of this system. So be sure to check that out.